Hi, everyone. So this is a screencast for tonight, which is Wednesday, September 6th. And tonight's homework is just going to be two parts. It's watching this screencast and then doing the homework at the end of this screencast, okay? So I start here with this question. I say, let the cosine of theta equal 2/3, and theta is between 0 degrees and 270 degrees. And the first question I ask here is, in which quadrant must theta terminate? Okay. Maybe you'll give yourself a chance just to write the question down, and then you'll replay me when you are ready to think out loud with me. Okay. So a couple of that's interesting things. It's saying the cosine of some angle theta is equal to 2/3. And when I look right here at this value of 2/3, I automatically do not recognize that cosine value as any of the memorized cosine values that I have around the unit circle. So right away, I know that this angle theta is not going to be 30, 45, 60, or 90, or any multiple of those angles. Okay, I'll say that again. I know that theta would not be a multiple of 30, 45, 60, 90, etc. Okay, but when I scan the rest of the question here, I'm never asked to find the value of theta, so that's good, right? I'm never asked to find a value of theta. I'm asked in part 3 to find sine theta and tan theta and secant theta, but I'm not asked to find the value of theta. Okay, so let's see here. In which quadrant must theta terminate? And we're told here that theta is between 0 and 270 degrees. I'm just going to put an axes here. And let's think about what we know about the sign SIGN of cosine. I know that cosine is positive in quadrant 1. It's negative in quadrant 2. It's negative in quadrant 3. And it's positive in quadrant 4. But quadrant 4 really isn't my concern because the possibilities for this angle, the angle could be between 0 degrees and 270. So if this is the initial, right, if this is the initial side of my angle, I know that as theta opens between 0 and 270, theta cannot be past 270 as per the instructions here. Well, the fact that cos of theta is 2/3 tells me that this angle theta must terminate somewhere in quadrant 1. So I'm just going to do this. This angle here, that must be theta. Okay? So theta must terminate in quadrant 1 because we notice that cosine is positive in quadrant 1. Okay, I know that. Okay. Oh, part 2, make a reasonably accurate sketch of theta. All right. And now what I'm going to do is the following. When I look at this, okay, when I look at the question 3, it says evaluate sine theta, tan theta, and secant theta. And I want you to think about something here. If you know that the cosine of theta equals 2/3, is there a way that I can incorporate this information into this drawing somehow by perhaps superimposing a right triangle? Well, let's see. If I just drop an altitude here and create a right triangle, okay, if the cos of theta is 2/3, that means that the adjacent side would equal 2 when the hypotenuse would equal 3. Okay, and now I have the hypotenuse and the leg of a right triangle, and I know then that the opposite side here is the square root of 5. Okay, so when I look at this, I now have kind of done two things. You'll notice a couple of things. Maybe you're saying to yourself, like, if I put a circle around here, right? If I put a circle around here, I wouldn't have a unit circle, would I? I would have a circle with a radius 3, all right? But the change in the radius won't change the value of the trigonometric ratios. And now I can answer part 3. The sine of theta will equal radical 5/3. The tangent of theta will equal radical 5/2. And the secant of theta, secant is the reciprocal of cosine, secant of theta will equal 3 over 2. Okay, try this one. Let me give you the second question. Let's say that, okay, I'm going to say this. I'm going to say, let's say if the sine of alpha equals -4/5 and alpha is between 90 degrees and 360 degrees. I'm going to say this. Find tangent of alpha. So this question, I'm not going to actually lead you through it. Like I'm not going to break it down like I did the first one. But what I'd like you to do here is first determine what quadrant alpha has to terminate in, and then go ahead and with whatever clear work you need, like above, see if you can find tan alpha, and then replay me. Okay, so I'm going to go ahead here and start doing this question, and sine of alpha is -4/5. That's interesting. And alpha is some angle between 90 degrees and 360. So this is my initial side of the angle, okay? The angle is going to be between 90 and 360, okay? But, oh, whoops, I have to do this. Sorry, let's make this 270. Sorry, you'll see why in a minute. Because here, when I have sine of alpha is -4/5, sine is positive in quadrant 2, negative in quadrant 3, negative in quadrant 4. When I said alpha could be between 90 and 360, that doesn't give you enough to narrow down where the angle has to terminate, so I'd change that. So the angle alpha is between 90 and 270. Well, if sine of an angle is positive in quadrant 2, that then tells me that alpha must terminate in quadrant 3. Okay, it has to terminate in quadrant 3. This is the angle alpha. And what I'm going to do now is superimpose a right triangle using the reference angle, right? So here is my right triangle. Drop the altitude to the x-axis, and here it is, right here. The reference angle for alpha is right there. And sine of alpha, right, this is the reference angle, is opposite over hypotenuse. So this length here is -4, negative in quotes, right, over 5. And this is the right angle here, and then by the Pythagorean theorem, that length is 3. So let's see, the tangent of alpha is going to equal opposite over adjacent, -4 over 3. Why negative? Because in quadrant 3, tangent is negative. How about no, come on, yam, tangent is positive, -4 over -3, sorry. Tangent of alpha is -4 over -3, or just +4 over 3, because in quadrant 3, tangent is positive. All sophomores whoops, that's not a verb. All sophomores teethe on coconuts. Okay, tan is positive. How about if I ask you for cosine of alpha? Cos of alpha would equal -3 over 5. Cosine is negative in quadrant 3. All right, so what we're looking here is at applied right triangle questions, but we're looking at applied right triangle questions when that angle theta can be above 90. Okay, how about this one? Let's see. Let's say the terminal side of theta passes through the point P, which is the point, okay, I'll do 5, -1. Okay, I'm going to say here, find the tangent of theta and the sine of theta. Okay, so a slightly different kind of question here. Let's highlight that too. Ooh. Okay. So, you know what? Draw this picture first. Go ahead and see if you can draw this picture and then replay me to see if you kind of interpreted this correctly. Well, let's see. Here's my, okay, and then here is the initial side of an angle. The initial side of the angle. And the terminal side passes through 5, -1. So I'm just going to call this point, maybe I'll call this point 5, -1. Oh, but then I have the question. Does she mean that the angle could look like this? Or is it possible that the angle could look like this? All right, boys and girls, the answer is here, you could have interpreted either of those two angles, the red or the green. And if you were feeling particularly crazy and wild, you could even rotate around again and spin around a couple times. So the way you interpret this question, yes, maybe theta is a negative angle, like the red one, how it opens downwards this way, okay? Maybe you interpreted theta as a positive angle that opened counterclockwise, okay? Now here's a question I have for you. Does it matter which angle, green or red, I interpret this as if this is what I'm going to be asked to find? The answer is no, it doesn't matter. Coterminal angles will have the same tan theta and sine theta. Okay, what is it about this point 5, -1? Well, once again, we can superimpose a right triangle. Look, let's just drop in altitude. This distance here would have to be 5. This distance is -1. And when you go ahead and find the length of the hypotenuse, this length here is going to be the square root of 26. I had no idea I had orange. That is the most exciting thing ever. Look at all, look at all the colors I have. I'm so excited. Ah! Very good. Okay, good. I'll use pink. All right. So now let's go ahead and find the tangent of theta. Well, let's see. Tangent of theta, we are in quadrant 4 where tangent is negative. Tan theta is opposite over adjacent. Tan theta is -1/5. Sine theta is also negative in quadrant 4, and sine is opposite over hypotenuse, so -1 over root 26. There you go. So your homework for this screencast is the following, okay? Oh my gosh, I just can't get over this. You got to look at this, look. Hold on, let me pause now. Can you believe this? Oh. Okay. Oh no, I didn't pause. Oh, that's so embarrassing. Okay. All right. The homework for this screencast is the following. Page 566, numbers. Let's see. Let's do 3. And let's do also 45. Okay. And let's do this. I think I'm going to have you go ahead and do, I think 40 and 44. You'll see what those are. That's just old news, just practicing. Okay. I think I also want to toss in here, let's do 51 as well. And then I also want you to ask this question. Is it true that the sine of an angle is equal exactly to the sine of negative theta? I want you to, is this true always? Is it true that the sine of an angle always equals sine of the negative angle? So in other words, does sine 45 equal sine -45? Does sine 50 equal sine -50? Does sine, oh, blimey, hold on a second. I want to do cosine, for heaven's sakes. Come on. Sorry. Is it true that the cosine of an angle equals the cosine of the negative angle? So does cosine of 45 degrees equal cos of -45 degrees? How about the cosine of, I don't know, 200 degrees? Will that equal the cosine of -200 degrees? Is that true? See if you can answer this question, being able to really clearly and convincingly explain why. Why? The most important questions begin with why. Okay, goodbye, everyone. Oh no. Oh.